Hello again everyone, Mr. Cruze here with another video for you. This time I'm teaching you a lesson even though I'm not present in the building. Remember, I'm at the admin building today on Wednesday, November 12th, 2014. So your task is to watch this video, figure out what's going on. It should be review. And then you can get started and probably finish your homework before you leave. Alright? So this chapter goes back to just dealing with plain old triangles, which is good because that's what trigonometry deals with, right? We start off with basic, simple stuff. Right triangle review. Just to recap, obviously a triangle is a right triangle as long as it has one right angle, right? As long as it has a right angle, it has to be a right triangle, of course. And we know several things about a right triangle. For instance, if I want to find the sine of either A or B in this case, right? In this particular case, sine of A, I'm just going to do everything from A. Sine of A is opposite over hypotenuse, which in this case would be A over C. And I use a little c like that with my little squiggle to symbolize the difference between big C and little c. Then we talk about the cosine of A, right? Cosine of A would be adjacent over hypotenuse, which in this case would be B over little c. And then we talk about the tangent of A, which of course we know is opposite over adjacent. This should all be a review for you. In this case, it'd be A over B. Okay. And again, we could do all these from the other angle as well, B, right? Sine and cosine would switch places, and tangent would just flip, all right? But we also have new ones that you might not have dealt with all that much in geometry, right? All of a sudden, we have this cosecant of A, right? Which is literally just the flip of sine. It's hypotenuse over opposite, so in this case, it'd be C over A. Then we have secant that goes with cosine, and again, it's just the flip, right? Hypotenuse over adjacent, which would be, in this case, C over B. And then the cotangent, I'm going to start tangent again, cotangent of A would be adjacent over opposite, and it just flips, right? B over A. Alright, hopefully that was a review for you, but we're going to be using that, and what we're going to be doing is actually solving these right triangles. That's what this is called, solving right triangles. So basically what will happen is you'll be given a triangle, you'll be given pieces of information as follows. In triangle ABC, C is the right angle, measure of angle A is 27 degrees, and the side little a, which is across from big A, is 31.4. They want us to find the length of B, the length of C, and the measure of angle B. Alright, and that's what we're going to be doing. We're basically going to be solving this triangle. We're going to have every side length and every angle measured by the end of this. Alright? Best thing you can do to start off is just draw the triangle. Really doesn't matter what it looks like, as long as it's a right triangle, of course, because it tells you it's a right triangle. You do have to make sure that C is the right angle, because that's what they tell you. But as far as where A and B are, it doesn't really matter. You could flip-flop those. It doesn't matter. I'm just going to put them like that. Alright? And start labeling things. Measure of angle A is 27 degrees, and A, which is the side across from little a, is 31.4. Again, C is across from C, B is across from B. Alright? So, let's find side length B first. Shouldn't be too hard, right? Here's what I would do. This is how I would do this problem. I would start from an angle that I know, 27 degrees. Never start from the right angle, but start from one of the acute angles that you know. And I would say, okay, do I know a side relative to that angle? And I do. It happens to be the opposite, right? 31.4 is opposite. Well, what is B relative to that angle? B is the adjacent, right? Well, what trig function involves adjacent and opposite? Well, we have two choices, actually, tangent and cotangent. I could do tangent of 27 degrees equals opposite over adjacent. I could do that. And to be honest, I think for the simplicity of this video, we're going to do that. Now, let me show you a little trick of proportions here. What you can do is you can actually switch these two values. So I can put B on top over here and switch it for tangent of 27. You can actually do that. That's a legal property of proportions. It's called switching the extremes, but it works, okay? So literally all you have to do is type it in your calculator, 31.4 divided by tangent of 27 degrees. Now, you must be careful. Obviously, we're in degree mode. Make sure you're not in radians. But B ends up being 61.62596987. I'm going to go ahead, since this side used 3 significant figures, I'm going to use 3 significant figures and do 61.6. Again, is this necessarily an exact value? No, because we did round, right? But there it is. Okay? For the record, you could have used cotangent 27 degrees. It would have given you b over 31.4. You could have multiplied, right? You would have just had to remember that cotangent is really 1 over tangent of 27. And you'll notice they end up being the same thing then. Okay? So that's fine. You can do it that way if you'd like. It's of no consequence to me. It doesn't bother me at all, however you want to do it. Alright? So that's part 1. Woo! Part 2 says find the length of C. Well, let's do the same thing. I technically have a couple options here. C is the hypotenuse, obviously. I could use the newfound 61.6, but here's the problem. If I use that, that's rounded already. I don't want to do that. I'm going to end up rounding on top of rounding, and that'll just make things even worse. Let's use the same 31.4 that they gave us to begin with. What trig function involves opposite over hypotenuse? I feel like this is Blue's Clues now, right? It's obviously sine. So, sine of 27 degrees equals 31.4 over C. Once again, let's use Mr. Cruze's little trick. C equals 31.4 divided by the sine of 27 degrees. Hopefully, this is review. You probably did something like this in geometry, alright? I get 69.2 once you round, okay? So C is approximately 69.2. Congratulations, you found all 3 sides. The last step is figure out angle B. That's part 3 there. And actually, I think this is the easiest part. You already know 2 angles in the triangle, right? How do you find the third angle of any triangle? Well, the angles always add up to, at least in our geometry, they add up to 180 degrees. So take 180 minus 27 degrees minus 90 degrees, and you will get the other angle of 63 degrees. It's that simple. Another way you could do this, by the way, is you could take 27 and 90, which is 117, and subtract them. Either way you prefer. You still get 63 degrees, and that's the measure of angle B. That's all we're doing today, solving for sides and solving for angles. Hopefully it shouldn't be too terrible. I'm going to do one more with you, alright? Just to make sure we got it. In triangle PQR, Q is the right angle, little q equals 147.6, and little r equals 72.15. You'll notice this time, we only have one angle, right? So we might have to do something a little more clever. I'm going to draw a triangle once again, a right triangle, because it tells me it's a right triangle. Q is the right angle. I don't necessarily care where P and R go, but they do tell me little q is 147.6, little r is 72.15, and I want to find everything else. Okay. Part 1 says find measure of angle P first. I'm going to call this, well, let's just call it P for now. From angle P, what sides do we have? Clearly I don't have the opposite, but I do have the adjacent and I do have the hypotenuse. Well, what trig function involves adjacent and hypotenuse? Cosine is what you should be screaming. Don't scream too loud, the sub is there. But cosine of angle P, whatever it is, equals adjacent over hypotenuse. How do I get the P out of the cosine? The answer is take the inverse cosine, right? And obviously we're talking about the principal value here, so realistically I can use the capital C cosine, right? Arc cosine. And all you have to do is type this in your calculator. Again, making sure that you're in degrees mode. So inverse cosine is 72.15 divided by 147.6 gives you an angle of roughly 60.74 degrees. Okay? So, I'm okay with 2 decimal places, that's fine. For the angle, that's okay. So there's angle P. Now, how do I find angle R? Well, there's actually 2 ways you could do this. Alright? You could say, well, from R, isn't this the opposite? And this is the hypotenuse, right? So what I can do is I can take the sine of R equals 72.15 over 147.6. I can take the inverse sine of all that, right? And when I do, I get 29.26 degrees. You might notice something about P and R. Quickly, if you add them in your head, you'll notice they add up to 90. This should make sense, right? All the angles in a triangle add up to 180. So I could have taken 180 minus 90 minus the first angle that I found, 60.74, and I also get 29.26. Take your pick, right? Whichever way you feel is easier. Alright, last but not least, we need to find this missing side over here. I don't know why I called it X. It's a little p, right? And again, you actually have a choice this time between what angle you pick to go from. I'm going to go from P since we're dealing with P, right? So, P is the opposite side, and you actually get a pick. Do you want to use tangent or cosine or sine, whichever you prefer? Well, cosine you can't use because you're using opposite. But I'm going to use sine just because I like sine. So the sine of 60.74 degrees, because I'm going from P, equals the opposite side over the hypotenuse. This time you can put this over 1 and you can do a little cross multiplication. So it's 147.6 times the sine of 60.74, and that'll equal whatever P is, right? So take 147.6 times the sine of 60.74, and you should get P is roughly 128.77. And it should make sense, right? The sides of your triangle should work, right? Everything should be nice. Okay, hopefully this section was a little easy for you. Really, it helps to draw out the picture and figure out what's going on. But there's really a lot of choices that you can take. Just be careful on your rounding. All right. Again, if you have any questions, I'm not completely out of the loop here. I will still be here after school. I will be here in the morning before first period if you do have questions. All right. As always, you can tweet me, email me, do whatever it takes to get a hold of me. All right. I wish you the best of luck. Your assignment that you will start working on now is on page 243, numbers 1 through 8 and 11. Okay, I would start with the odds and make sure that I know what I'm doing. All right, good luck and be good for the sub, and I will see you later.